Hey guys, this is Luke again with Crusader Machining. Class is in session, and today we are going to be going over another can cycle that I use often that, again, years ago I never did. It is called G83. Okay, G83 is a peck drilling can cycle. We're going to go over the anatomy of the G83 later in the video, but right now we're going to go over a couple reasons on why I like to use G83, but also reasons that maybe it's not practical. So on some of our machines here, we have high pressure coolant and through the turret coolant, through the tool coolant. Certain machines, older ones, they do not have coolant that goes through the tool or through the turret. It's just flood coolant with a little bit of lock line that's shooting water or coolant or oil at the workpiece. You can get the water in there, but when you're drilling, especially deep drilling, the hole is dry. So what a lot of people would do is they drill a portion of it, they'd wrap it back out, let the flood get into the hole, and then they would proceed back with the drilling to make sure that the part and the tool were staying cool and it was flushing out any chips that were in there. So I like to use G83 for that same reason. If I have a machine that has weak coolant, or if I'm using like a high-speed steel drill that doesn't have holes for cooling through, a lot of times I'll peck. So the benefit of using a peck drilling cycle like G83 is you can set a certain distance that you want it to drill, say a half inch, 0.5, 500 thousandths, that it's gonna drill in 500 thousandths, it's gonna wrap it back to your position, then it's gonna go wrap it back in, feed, wrap it out, wrap it in, feed, at a set drilling depth. So benefits for that, pulls the chips out, lets them fall, lets coolant get in there. There's certain times that you don't want to use G83. So one reason that I would not use G83 is if you have high pressure coolant through the tool. You don't need it. You have the helix in the drill made to evacuate the chips. As you're drilling down, that chip is going to come out. If you have high pressure coolant, I mean, maybe even 3, 4, 500, some of our machines have 1,000, you're blowing those chips right out. You really don't need it. So, and one bad thing about using G83 when you don't need it, if you drill in your hole and you come back out, your hole could be full of chips and you don't know it yet. And you ram it right back into them, or drilling over chips sitting in the bottom. So I'm not going to say that G83 is a cycle that everyone should use all the time. It has its applications, but there's times that it can actually be detrimental to your part, and especially your drill, like a carbide drill. The cutting edges are real sharp, real strong, but they can also be quite fragile. So if you're drilling down there and your part is full of chips and you wrap it out and you wrap it back into the hole, you could land right on those chips that you're gonna either wrap it into or you're drilling back into. So I do like G83 for certain applications, but it's not a cure-all type of can cycle. But it is a good can cycle for drilling that every programmer, setup, or operator should know or want to learn about. You can change that feed rate easily right at the screen. You can change your cutting depth right there, right at that can cycle. So I like G83, but it's not a cure-all. Let's get into the video. We're gonna go over a little bit more, a diagram of what it is so we can see what each part means, and then we're gonna go over watching an actual G83 in action. So there's one major thing that I missed in the intro. I was editing the video yesterday and I realized one of the main things that I missed about the G83 is for deep hole drilling. I think I may have briefly touched on it, but if I had to say one of the best uses for G83 out there, or one of the main uses, is deep hole drilling. When obviously, as the name implies, when your drill is way deep in your part and there's zero chance that you're going to get any coolant in there, you need to come out and evacuate and fill the hole with coolant again. So like I say, I think I briefly mentioned on it in my intro, but I wanted to reiterate that and emphasize it. Deep G83 is excellent for deep hole drilling cycles. And here's an example of a G83 peck cycle and a piece of brass that I did earlier in the week. And here you can see a little diagram of the G83. Notice, of course, the G83, the Z, the R, the Q, and the F. The Z is your final drill depth. The R is your retract value. How far are you going to come out from your Z0 and positive before you go to your next peck? Q is your pecking depth. F is the feed rate of the drill, and G99 it would be feet per revolution. G98 would be inches per minute. And your Q pecking depth is interesting because what you set for the Q, like here in the example is Q2000, what you set for the Q, the number of digits that you set with the Q have to do with how many digits you can offset. So on some of our Swiss machines, we can go down to 5 decimal places, so our Q has to be in 5 decimal places. Other machines is 4 decimal places, like down to the 10th, so our Q has to be that. So this example, Q2000, means it's pecking every 200. So every time it goes in to drill, it's going to drill 200, then it's going to come back to that R plane, wrap it back in, drill another 200, wrap it back out to that R plane, wrap it back in, drill another 200. And of course your feed rate, the feed rate of your drill, this example with I see is a little bit cut off, is 008, is 8 thou per revolution. That would be set from your manufacturer's recommendations. Now what you see here is a very complex program that I wrote really quick for this example. Just kidding, not very complex at all, but a silly attempt at humor. So here we have a little program that we wrote. You can see the first line, we're going to GOZ.1 X0. When you're drilling on a lathe, unless you have an offset drill, you want to be at X0. I'm calling up G99, G97. Turn on my RPM on the next line, G97, 1500 M3, cooling on. Now we get to the bread and butter of this very complicated program, is your G83. G83 Z negative 1.5, R50, Q2000, feet of 8. So in this, we can see I'm going to drill to a final drill depth of negative 1.5 for my Z0. I am going to rapid back to 50, my R plane is 50, which would mean I'm 50 thousandths away in positive axis from Z0, and I'm going to be drilling in 200 thousandths every peck at a feet of 8 thou per revolution. Then I'm going to rapid back to Z.5, GOG28 UW, go home, M30, reset, rewind. Now, the Q, or excuse me, not the Q, when you're drilling in 200 thousandths, you wrap it out to the R plane, then you're going to wrap it back in. I've had a lot of people say, well, do you just wrap it back in and hit material? No, generally you're 50 thousandths away from the last spot that you drilled as you wrap it back into the hole. So you drill 200, you wrap it back out to 50 above and Z for this example, that's your retract plane. Then you're going to wrap it back in. You're not going to wrap it back in and hit the material. You're going to wrap it back into 50 thousandths away, but you can set that value, excuse me, in a parameter, at least on a FANUC. You can set that on a parameter. So this is just a little program example I wanted to show. Maybe I went a little too far showing the G83 examples, but I really like this one, how you can see it wrap it out and where it goes back to. So in conclusion, we went over what is a G83, why do you want to use a G83, why you might not want to. We went over what each section of the code looks like. It's not as complicated as the G71 that we had looked at in a previous video, but it's important, of course, to know what it is, especially that Q value. That's going to change your cutting depth, which an operator or a programmer can do right there at the control if you want to make the depth deeper, more shallow, whatever it might be. So we want to use G83 to evacuate chips and to get more coolant in the hole if we don't have sufficient coolant through the tool. One of the reasons that you might not want to use G83 is it can be dangerous to wrap it out and wrap it back in onto the chips and cut on those loose chips in there. Your drill wants to stay engaged in the material. It wants to stay engaged. Use that helix to draw the chips out. So anytime that you're repeatedly coming in and out of a hole, especially I'd say my experience is like 52-100, tool steels, anything hard, it can be a little bit of a problem using G83. And if you have good coolant pressure through the tool and you can keep that drill engaged, I would advise that. But certain times you can't. We have some older machines here from 2000, 2005. The coolant pressure is horrible and it's simply just flood coolant. You can't, the drill is drilling deep. And in another video, we're gonna go over drill depths, like what is your 2 times deep, 5 times deep, 10 times deep. Certain times you have to pull out, but there's other times that you don't want to. So in conclusion, we went over G83 today. I hope you guys enjoyed the video. Thank you very much for watching and please subscribe. Thank you.